Hey, good afternoon, everybody. Apologies for getting started a little late here today. Hope everybody can hear me now. I see, all right, it looks like we have everybody tuned in now. Great. So thank you again for joining our Kubernetes Masterclass. Today is Tuesday, June 2nd. Our topic today is running a multi-cluster service mesh in Rancher. I am Connie Lin. I'm the manager of global events here at Rancher and will be your host today. Our speaker today is Jason Skrzypek, field engineer here at Rancher Labs. Jason, you want to say hello?
Hello, everybody. Thank you for coming in and watching my session.
Great to have you here today. So before we jump in to the session today, just a couple housekeeping items. Our class today will run anywhere between 45 to 75 minutes. We welcome lots of questions, so please utilize the questions panel on your GoToWebinar dashboard if you do have any questions that come up. The session is being recorded. We will share the recording and the slides after the event via follow-up email. So if you have to drop off early, no worries, we will share the content. If you have not yet, hop on over to our Rancher users Slack channel to join in the conversation about this masterclass and every week when it takes place. A couple upcoming online trainings. You can view them all at rancher.com/training. Every week, didn't mean to go forward there. Every week we do have an intro to Kubernetes and Rancher training, along with our Kubernetes masterclasses on Tuesdays. Our next masterclass is June 9th. And next week we also have our monthly online meetup covering all things Longhorn, which just went GA today. So with that, I will hand it over to Jason to go ahead and get started with today's topic.
Hello, everybody. As Connie mentioned, I'm a field engineer with Rancher Labs. Today's masterclass is going to be multi-cluster service mesh. I've been working on it I've been working in the Kubernetes space for probably the last 4 or 5 years at this point in time. Cool, thank you. I'm reading the questions as they come in. So if I say things that don't seem sensible, that's because a question, I'm just confirming a question. But I've been working with Istio specifically for the last couple of years, Istio obviously being on top of Kubernetes. And I've been getting a lot more questions lately as to how to run a multi-cluster mesh, whether or not you should run a multi-cluster mesh, or some of the questions that are regarding it. So I thought this would be a good opportunity to share what I've learned, share some perspective, and maybe get some perspective back from people that are either already using Istio and have designs for running a multi-cluster mesh, or have a full multi-cluster mesh and just want to show me what they're doing. So I have a few slides. I think it's somewhere in the neighborhood of 25 to 30. I would like to go slide light, kind of breeze through some of the content there, and then get into the technical part, because there's a lot of edge cases, and there's a lot of interesting things you could do with Istio specifically, and then Istio as a multi-cluster mesh. Just to make sure I can cover all of it. If I'm going too fast, please make a mention in the question section. I'll slow down and I'll address things as they come in. So the first thing I'm going to talk about is a little bit of background. Then, as I discussed, I will be using Istio as the multi-cluster service mesh. I know there are other options out there, but this is the one that the horse that I'm tied to right now. After that, we should have a good enough groundwork to start discussing the actual demos. The first demo being, for those of you who are familiar with Istio, might be familiar with this demo. It's the book info application. It's basically a 4 microservice application that's distributed in a way with multiple versions of each service. We'll talk about how to make that span a cluster boundary. And then we'll talk about something called Admiral. Admiral being an automation agent that will see the utility of and the use case for as we're going through the book info application. And then I'll wrap up with where I see this discussion going at large and who the major players will be in the coming months/year. Cool. So to lay the groundwork, this class will be helpful if you understand the basic value proposition of service mesh. So if any of these concepts seem unfamiliar, then I would definitely do a little bit of Googling, or on the next slide, I post a link to a previous masterclass that goes over them in a little bit more detail. Basically, you would be in a multi-cluster service mesh class because you understand the value of traffic shifting, request transformation, circuit breaking, MTLS, and tracing, so on and so forth, that a service mesh provides, and understand that there's not too much keeping a service on one cluster from acting like a service on another cluster, or no understanding that need exists. Secondly, this Istio that spans multi-clusters wouldn't be very useful if you're an organization that's only running one cluster. So there's kind of an implicit requirement here that you're spanning either multiple cloud providers, maybe you have clusters in AWS and GCP and Azure, maybe you just want to span from the cloud to your on-prem data center, or maybe you just have a complicated networking scheme with your on-prem locations. The more the merrier, I guess, in this case, because as what we're trying to accomplish here is to bring them all together. And so the more different perspectives you have, the more different angles and the more configuration that you can start to apply to your Istio multi-cluster mesh. Another thing that would be useful for anybody that's watching this presentation is that if you have more than one Kubernetes practitioner in your organization, and what that's more or less leveraging is your ability to spin up multiple clusters and kind of have some autonomy. So maybe in your organization, you have a set of microservices devoted towards one arm, and then you have another set of microservices devoted towards another arm. If they each were to be fully integrated into a Kubernetes platform, it would be beneficial for you guys for this presentation if those clusters kind of moved independently. So maybe like one cluster is has an update cadence that's a little bit faster than the other cluster. Maybe the one cluster has a different CNI or something like that. But having clusters that are independently resolvable kind of gives the groundwork for why you might want to run a multi-cluster mesh. And then lastly, the 2 points on the bottom are, if you're running Istio already, you kind of understand a bunch of that already. And then as long as you appreciate that this solution is just one instance, one opinionated solution, it's not going to solve all of your troubles. The opposite of that, this class will not be helpful if you're playing buzzword bingo. If you've seen that Istio and service mesh is all the rage, and you think that it's going to multiply your productivity without actually having the knowledge base there or the use case that drives that, you're going to be sorely mistaken. Again, if you're not familiar with Istio or its components, we have the previous masterclass done by one of my peers, Eamon Bauman. It's called Understanding and Implementing Service Mesh. I know that link doesn't mean anything to you guys because you're probably not going to copy and paste that right now. All these slides will be available later and through the recording. If you have difficulty communicating between clusters, establishing a multi-cluster service mesh is going to also be difficult. It's not going to make it any easier. You're still going to have to go through maybe that change control process to get a hole poked in the firewall between the clusters. Maybe you have multiple proxies sitting in the path. You certainly can move forward with a multi-cluster if you understand that it's going to be an uphill battle in that regard. But I leave that to you. And one last thing here I want to mention. The last one's kind of a joke. the second to last point is if you're already running low on compute resources, running a service mesh in your cluster is significant. I'll go over at later point when we actually have Istio clusters to point to that you will be running workloads to support this multi-cluster mesh. And therefore, if you're already maxing out your CPUs or your memory, you're not going to be able to add these additional components. So, as I mentioned previously, the reason this conversation kind of starts is that most people discover that service mesh does in fact add a benefit to their organization, being able to shift traffic, transform requests, do some circuit breaking, and do some authentication. That isn't scoped to a cluster. Having an application running in a pod or a deployment or some sort of workload in one cluster, it doesn't really care where it's running as long as it has an endpoint and it communicates under the same protocol. So a couple of the leading questions that I often see, like I said previously, that I've been receiving a lot of questions that kind of sent me down this direction. What if I wanted to set up multiple versions of different apps on different clusters? What if global policy dictates that all traffic in a cluster or in my organization at large has specific header format, has specific payload tags or something like that? What if I need full fault tolerance across all of my data centers? What if I need an application to be 100% uptime and I need the application to live in cluster A, cluster B, and cluster C, regardless of where they are? We have MTLS. I think MTLS is something that people should just want across all of their traffic. It just validates the authenticity of each service, so you don't have any man-in-the-middle attacks or anything like that. And then tracing, we have, if you go from the monolith pre-service mesh to what we have now with the microservices, there's distributed tracing is one of the key features there that allows you to kind of debug and find out where things are failing, where things are taking in a lot of latency. And generally speaking, just what's happening once traffic hits your boundary, or once traffic hits the cluster boundary. It's pretty paramount that we keep that going across multiple clusters if we have traffic going across multiple clusters. So the other point being that you're probably running, if you're running Kubernetes, or if you're running much compute these days, you're either running it on-prem solely, or on-prem and with a cloud provider, or across all of the cloud providers. Chances are you're not just running it in one isolated location. Moving to the cloud kind of dictates, if you want to get the benefits of being on the cloud, that you distribute your workloads accordingly. So a service mesh kind of abstracts that away, and it gives you the ability to treat everything kind of as the same single object, or at least it's on the same sort of networking scheme. And then lastly, as far as laying the groundwork goes, Kubernetes, we've seen a trend, or at least I've seen a trend most recently, in that originally with Kubernetes, because of the difficulty in spinning things up and getting a Kubernetes cluster and the lack of Kubernetes talent, they were large single clusters. But now that Kubernetes talent is becoming more prevalent and we're getting more and more tooling to support automated deployments, it's really easy to spin it up, and we're starting to move in trend to where clusters themselves are becoming a commodity, where maybe in an organization, you're regularly spinning up multiple clusters to do specific workloads, specific tasks, maybe even spinning them down in your CI/CD workloads. That with the multi-cluster sprawling, you have countless different distinguishing features among those different clusters that could cause problems when you're trying to connect cluster to cluster to cluster. For instance, I got this off the CNCF webpage. There are over 90 certified Kubernetes offerings. And in my travels, I've seen people that even though they think that they're the Kubernetes, they're kind of the one-stop shop for Kubernetes in their organization, some other part of the organization is running some open source version of Kubernetes, or they've installed Kubernetes, they're running their workloads in some sort of skunkworks cloud project. Kubernetes, as I'm pretty sure you're all aware, that Kubernetes moves really quickly. Depending on the distribution you've chosen and the strength of automation, you could be in your organization supporting as many as 5 minor versions at a time, maybe more. With each of the versions, sometimes there are breaking changes across the APIs, and we kind of want to bubble above that and have one consistent Kubernetes feel across our environment. And then lastly, I'd be remiss if I didn't mention any of the security components. There's no sense in running a fully secure cluster if the information and the workloads on top of that don't have that security requirement. But the opposite being also true, that if you have a high security posture, it's very important that you are locking down your cluster with bot security policies, network policy, RBAC, open policy agent, gatekeeper. But with all these things combined, generally speaking, you'll see lots of different types of clusters. And that's kind of more or less what this I'm visually trying to represent with all of the Rancher cattle here. That I'm pretty sure a bunch of you already knew that. And so what we're here to discuss is that a multi-cluster service mesh can bring them all together. And what we're going to do today is we're going to set up a multi-cluster mesh with Istio and Rancher. As I'm often, as I would question my judgment, somebody who's taking a masterclass, I like to explain my rationale. And so I'm going to be going through a couple of the questions and concerns that I had as I was going through this process. And here's just for your reference, some of the reasons why I made the decisions that I did. First and foremost, why Istio? Istio, there's a bunch of other options out there. There's Console, there's Linkerd, there's Mesh, there's Kuma. Why am I using Istio? It's open source, it's free to run. There's a significant community following, so it's not difficult to track down problems, maybe find something in a GitHub issue, maybe Stack Overflow. But there's a lot of people running under the same constraints. And secondly, there's documentation. The documentation itself, it's at Istio, and I'll probably bring it up at some point in time when I'm doing the demo. They have documentation as a first party, what's the word I'm thinking of? It doesn't matter. On their website, they have both replicated and shared control plane Istio instructions front and right at the front with your installation options. First-class citizen, that's what I was thinking of. The multi-cluster options are first-class citizen as far as Istio is concerned, whereas a couple of the other service meshes, they kind of hide or obscure what the multi-cluster options are just because they may or may not be fully fleshed out. On the other side of that, the infrastructure side of that, why am I choosing Rancher? Because I'm trying to exhibit the utility in a service mesh, a multi-cluster service mesh. I'd like to be able to demo against various types of Kubernetes clusters hosted in various regions on various platforms. Rancher does a great job at giving me access to hosted Kubernetes providers, giving me access to generic vanilla Kubernetes that I can import it. And it also gives me a pretty straightforward way to generate clusters, as we'll see in a little bit. It's also open source. Everything that Rancher Labs does is open source and available for free. We work on a support model. It's, again, like my previous statement, cloud agnostic, and I can use vanilla Kubernetes. So starting our way down the opinion path, would I suggest using self-managed or hosted Kubernetes? Do you need to, assuming that we're working with Rancher, you have both options available to you. That's what this snapshot is from. This is technically the driver option so that you can add, subtract GKS or GKE, AKS, EKS from the cluster drivers, and the node drivers being VMware, and then the various EC2 machine instances and stuff like that. But the main reason that I made the decision that I did to go with self-managed Kubernetes is not a requirement for, as far as multi-cluster mesh is concerned, but it kept me open in the event that I wanted to go through. I wanted to go through with the same process in different environments. You can see the first bullet point here, indicating that even though Istio is supported across all the major hosted providers and the multi-cluster instance is as well, there are separate sections for a couple of the Kubernetes distros. GKE has a CNI installation setting that you need to add on to before you can install Istio. One of the caveats moving forward that I learned, I guess, after the fact, is that when I'm running Istio in self-managed mode, it means I'm responsible for the cloud provider. So if I want to use, I could always use node ports, but things become a lot more straightforward when they're actually fronted by a cloud-generated load balancer. I will be using Amazon Elastic load balancers for the demos. And that's what that says there. And I have a link here for how to set that up in your environment. One thing that's more or less an aside, it's not a decision point, but each time you, in order to install a multi-cluster mesh with MTLS, you need to generate intermediate certs under the same root cert. I would take, there's a warning on the Istio website. Oh, there's questions. Oh, nothing. I'll talk about that in a little bit. So as far as the certificates go, I would generate new certs for all of your tests, because you never know when a test environment is going to be upgraded into a more production-like traffic without you knowing, or production-like environment without you knowing. In the Istio sample repo, there's a make file, and it's real straightforward. It's just make root CA, and then it's make name of the cluster, certs. You get all the certs, and then you just need to do a kubectl apply command to apply those. Assuming that I've started down the Rancher path on self-managed, I've gone through, maybe I've generated a couple clusters, and I've installed the secrets of the certs. How am I going to be installing Istio? Again, this is kind of a non-question based on one of the earlier questions one of the earlier opinions that I made, in that I chose Rancher. Rancher comes pre-bundled with Istio and Istio integration. That Istio integration is leveraging Helm. It is leveraging Helm, and it's Istio, I think at this time it's currently Istio 1.4.7 or 1.4.8. I know that Istio is, the most recent Istio to be released is 1.6 point something, and there's a breaking change between the 1.4 releases and the 1.5 and 1.6 releases. But I kind of wanted to work with where I was. I don't know how long this video will last on the internet. I just want to make sure that I'm pretty clear about that it's backwards compatible up to the current point in time, I suppose. Oh, there is a relevant question here that I want to answer. Is why Helm installation will be deprecated? What is the reason behind that? You can see on bullet point 3 that Istio CTL leverages the operator but adds user input validation to prevent incorrect configurations. Helm, it's not as straightforward to do the input validation. And the combination of Istio CTL, the operator, and something called customize with a K will give you the fine-grained access you need, the security to know that you're not sending invalid configurations towards your cluster, and it kind of set, those are the 2 points, but I think the third point being that the operator installation more modular, and the way that the Helm chart installation, there was kind of an overarching dependency structure, whereas Istio is moving in a direction where things are independently movable. That's a good question. But for the time being, we will be using Helm. Again, it works with a multi-cluster configuration, and that's what we'll go forward with. At some point in time, Rancher will be upgrading to 1.6, 1.6.x, and ultimately it won't matter to the underlying user what the actual installation method is, as long as we expose the proper configuration options. So moving on with questions. I had mentioned earlier that with Istio, you have the option of sharing a control plane or making a replicated control plane in each cluster. Basically, the TLDR here is that the value, there's not that much less that you're doing in the shared control plane model that makes the lack of availability and the configuration spread and the lack of resiliency a useful exercise. Generally speaking, creating the only thing I would suggest against a replicated control plane would be if you're running very minimal instances and you just don't have the compute to support multiple control planes. But I would kind of more or less use the standard consider the standard to be the replicated control plane model, because as we'll see, it's real straightforward. It's basically just install a cluster, rinse, repeat. We're almost there, I swear. And I will be showing the demo of this and making references back to a couple of these points later. But once we've gone through, we've decided that we want to use a replicated control plane of an Istio cluster on Rancher. We're going to use the Helm install. That Helm install is going to, by default, have Kiali Jaeger enabled. That's how we get the integration into the UI. It's going to have Mixer Pilot Galley gateways enabled. Again, it's a 1.4. I know that Istio kind of restructured into Istio D most recently. The functionality is more or less the same though. Cert Manager will be disabled. Monitoring will be enabled, so we'll be able to scale things based on my metrics. And the CNI enabled will be false. We will be using another question I didn't actually put in this slide deck. We will be using auto-injected sidecars, not using the CNI to do the init containers. Things that we need to add to this Helm chart through the custom options for the multi-cluster configuration is we need to enable MTLS at the global level. We need to enable something, a flag that's multi-cluster. We need to enable core DNS so that we can route from within the cluster to external to the cluster. And then we need to actually designate what the external communication, where the external communication will be resolved. And then because I am using the cloud provider, like I mentioned earlier, I will be using a load balancer, and I will be using, and I won't be using any of the authentication attributed to Galley. It'll all be public and available. So this is more or less what the YAML looks like there. You can see that it's condensed. One thing I want to mention here is that if you're going to install it in Rancher, it's going to be flattened. The global.mtls should be expanded if it's a true YAML. But here you can see it's the global.mtls.enabled, global.multicluster, so on and so forth. The arrays have the indexes in them, but the way that the YAML is being interpreted through the UI, this is how you have to put it in there. And the last thing, the last decision, the last configuration option that we have available that we have to make is where we're actually pointing the DNS, plumbing it all together. Make sure that you choose the right DNS settings for your cluster. There's kubedns, which I wasn't using. I was using core DNS, and core DNS is a little bit, there's an opinionated change. There's a change that happened in 1.4, and I think 1.4 beyond, that the Istio documentation makes a reference to. I was running Istio 1.4 dot something, so I just used the most recent core DNS configuration. All right. So technically, assuming that we've gone through all of those choices, we've gone to the commands that correlate with them, we would have a multi-cluster mesh. But that multi-cluster mesh wouldn't be very useful, either because it doesn't have any services or because we haven't actually connected any of the services together. The services, in order to actually make the cluster mesh span multiple clusters, you have to use these 4 objects in various configurations. First being service entries. Service entries are what's actually adding the external clusters as service entries in the source cluster. They have to have addresses associated with them. I would follow the instructions that Istio provides and put them in the class E range, 240.0.0.0 and above, just so you don't collide with any masks or anything like that. Secondly, the destination rules. The destination rules take care of what's routed to the global DNS, making sure that you're load balancing, giving you the ability to provide weights to the various cluster endpoints. Virtual services being, again, on the source cluster, they will handle, maybe if you want to spread work across a local instance and a remote instance, they allow something called mirroring. And then lastly, there's gateways. You have the option to do an ingress and an egress gateway. Ingress gateway being the way that we're handling the mutual TLS from cluster to cluster. Egress gateway being more helpful for firewalling to make sure that you're using a single source IP. Cool. So that's a lot of talking. I had a couple questions that happened throughout that. Let me see, just go through the questions tab, see if there's anything that I need to answer to the group at large, then we'll get into the demo. One of the questions was, is it possible to run a Kubernetes or to run a multi-cluster configuration of Istio with different Kubernetes versions? Yes, as long as there's the compatibility among all of the Istio components, the traffic would be able to cross over just fine. What happens if I need to upgrade to Istio 1.5? When I upgrade to 1.5 in the Rancher UI, it did not recognize the new Istio, even though it was installed on the cluster and working. I could not use the Istio in the UI as their way to fix it. The reason that Istio 1.6 came out is because the migration strategy from 1.4 to 1.5 just doesn't exist. More or less, we're going to be supporting the transition from 1.4 to 1.6 because 1.5 introduced a lot of breaking changes and didn't connect the two together. What can we use to do load balancing on a multiple cluster just egress? Well, I will be using load balancers for the ingress. I'll make it a point to mention that show that a little bit. But you could put a load balancer after the egress. That would be perfectly fine. I think that kind of defeats the purpose though. That would be something that you would be concerned more on the destination side. All right. So I hope that answers a fair bit of those questions. I'm going to move into the demo because I am talking for a lot and I'm not showing very much. We're going to be using the book info project as opposed to the normal book info project, which you deploy on a single cluster. We're going to be deploying it on multiple clusters. As you can see here on the left, product page has its own cluster, the review service has its own cluster, details, ratings, and so forth. And then there's information about the book info project, but that'll become more apparent when I actually do the demo. Let's get out of here. All right. So as far as the book info project goes, let's open up Istio multi-cluster. We go to examples, book info application. Here you can see a similar diagram. Basically, communication happens from the product page, goes to the review service. That review service goes to ratings, and also from the product page to the details page. What I want to do actually is I want to go and install that. I have a couple clusters here already that I'll reveal in a little bit, but this book info product page doesn't have Istio installed on it. You can see that there's no Istio components here. If I go here and if I go click on tools, click on Istio, I have a couple options available to me. If you remember, I said that I was allowing group access, allowing all authenticated members to access Galley and Jaeger. That's just so I don't have to worry about RBAC. The ingress gateway, I connected a cloud provider. So I'm going to enable that to true. And I'm going to set that to a load balancer. I don't need to fill out the IP because it's just going to auto-generate the load balancer. I'm going to keep all that the same. These other options, pilot, mixer, and tracing, more or less, if you need to make changes to the limits and reservations, feel free to. But I'm just going to keep it all enabled and at the default settings. The thing that's important here is this custom answer section. This custom answer section, let's open VS Code, is where we dump that flattened YAML that we saw earlier. I have it saved in VS Code. I paste it in there with just a Control V. You can see it auto expands everything, and that way we don't have interesting behavior with the nesting of the various keys. Like I said earlier, this is just enabling multi-cluster, enabling the egress gateway, globally enabling MTLS, and setting up the DNS rules. Click enable there. See it saved. If we go into the system namespace, we go into apps. We will see the 3 Helm charts that are supporting the cluster, the Istio installation. These 2, monitoring, operating, and cluster monitoring, being how metrics are being thrown into the Istio installation. And at some point in time, we should see this 12 go from 12 initializing to 12 running. It takes a little bit of time. But more or less that's going through for full perspective. That's going through and creating Citadel, egress gateway, Galley, ingress gateway, pilot, sidecar injector, telemetry tracing, core DNS, Galley. And again, I know that 1.6, 1.5 and 1.6 moved over to Istio-D. So those basically all just collapse into one daemon. But for the time being, this is what we have. Cluster monitoring has to finish for a bunch of these components to finish too. It should only take a couple more seconds. What I can show you is what we're going to get. Let's go to book info details. No, let's actually go to book info reviews. Boom. Book info reviews, I already have Istio installed. If we go to Istio, you can see that it's already installed. If I go into the default project and I go into this Istio tab under resources, you can see I have traffic metrics, traffic graph, gateways, destination rule, virtual services. And down here I have Kiali with the pre-installed book info project. So similar to what we saw in the diagram, you have product page, which is basically the entry point. You have a detail service. You have a review service, and then you have a rating service. One thing to note here is that, well, that's an artifact of this period here. It's not currently receiving any traffic. Let's send some traffic to it. In order to send traffic to this guy, let's go to system. We'll go to workloads. We'll look at services. We need to get the load balancer's IP address. So we look at that. Let's view edit YAML. Here down at the bottom, you'll see the host name. Copy that guy. I need to add the right endpoint. There we go. So this is just the front end for the book info project. I'm actually going to, while do curl, let's make sure curl product page dev null, done. That should be sending traffic. Now if we go back to Kiali, we can see default, Istio, traffic graph. There we go. That's the current state of the cluster. Traffic is flowing freely from the product page to both the details and the review service, and then it's going actually off cluster. You'll notice that each of these boxes corresponds with a deployment. A deployment, and then this is a kind of like a home plate that we don't see anywhere else. What's actually happening there is that traffic is being routed off cluster, and I could show you that traffic is being received by the ratings.default.global cluster. But first, I want to show you the components that are required to make that happen. Destination rule being one of them. We have here a ratings.default.global destination rule. Let's actually view it through the YAML. View edit YAML. Basically, the spec here is that the host is the ratings.default.global. We're going to point it to all of the labeled versions, v1, v2, v2 MySQL, v2 MySQL VM. Those are just for the off cases that you want to use Istio on a VM. And the traffic policy is going to be mutual TLS. Once we have a destination rule, then we need a service entry. That service entry isn't actually reported here. We're going to have to go into the dashboard to view it. What we see here on the left, those of you who might not be familiar with the experimental UI, you could select the cluster in the dropdown on the left. We were in the reviews cluster. We could select whether or not we want all namespaces, all system namespaces, or all namespaces in total. This is all being done in user namespaces, so I'm just going to keep that the same. And on the left, you see a much more comprehensive view of all of the resources that a cluster contains. We care about the Istio components in this point. We can see that destination rule that I just showed. There's the YAML for it. We also want to see the service entry. The service entry being what's actually pointing to the remote load balancer. Again, here is the required address, even though it doesn't actually accomplish anything. Then there's the port, 15443 being the MTLS port, so that the traffic is assumed make sure that it's authenticated. The hosts that we're pointing here are ratings.default.global. And then lastly, the service is being exposed on port 9080. So that gives us a destination rule and a service entry. The destination rule being, again, how you're distributing the traffic. The service entry being the actual connection. And then a virtual service being the thing that pulls the current existing ratings service, because there's already a rating service in this cluster, and sends it to the default global service instead, again on port 9080. So with all three of those set up, we have, if we go back to Rancher, what you'll see there is, let's just double check that we're still getting the same traffic. That every minute, see traffic still flowing freely. If we go to the rating service on the ratings cluster, which also has Istio installed and it's also been meshed together, you go to default, you see the traffic graph, and down here, if we look at the last 1 minute, let's request percentage, and let's talk about that. We are actually receiving the traffic coming from the other cluster. Because we see this key here, we know that it's MTLS, and the traffic is flowing freely in there. Cool. So let me just double check time-wise what's going on. 2:50. I can talk about more components as far as the Istio mesh is concerned. Does anybody have any questions about the components that are required here and what the actual traffic is being represented as? Or would they want to see anything specifically before I move on? Need a couple seconds for questions. All right, I don't see anything new exactly. So I'm going to cut back to the presentation because I am talking, I'm taking a little bit longer than I expected to. There's a second demo component, and that second demo component has a little bit more wow factor. So if we go back to PowerPoint, yeah, I do want to make a mention of this note here that Chiali and Jaeger don't yet cross cluster boundaries. You notice that we had the key. We knew that it was MTLS, but we didn't know exactly what cluster came from. That's still being decided upon with the Chiali developers. Cool. So as you might be able to understand, if you wanted to, let's actually switch back to this cluster. I have just for this service, I have 4 clusters. If I wanted to connect all of the possible permutations of service to service, that would be at minimum three additional YAML manifests per service. So 3 times in each, 3 times 4 for cluster, so 12, and then 12 times 1, 2, 3, 4, then 12 times 3. So 36. So that'd be 36 different manifests that I'd have to keep track of. I mean, it's doable, but it's not something that I'd want to go into work and enjoy myself doing every day. Enter Admiral. Admiral is an automation agent that kind of takes the manual control out of that. Consider it something. It's a controller for the various manifests that we already talked about that lives on a centralized cluster. The way it operates is that you more or less establish a dependency on various clusters to various services, and then you determine a global traffic policy to distribute traffic across those different services. And I think that it's a great step forward in improving multi-cluster user experience. That way you don't have to go in and manually create a service entry every time now. I think I have one more slide. Yeah. A little bit deeper into the Admiral architecture. Like I said, there's a control, kind of a privileged control tower. This CL1. It hosts the Admiral controller workload, the credentials to communicate with both clusters through kubectl, and then the dependency records, which tells you which clusters need to have which components installed on them. These other 2 clusters, being the controlled clusters, CL2 and CL3, they have Istio. It's a replicated control scheme. They each technically have an ingress. This diagram just didn't have another ingress there. And well, I guess they each technically have a server. This is just off the Admiral documentation. I kind of went one step above their demo. But what I'm going to show you today in a couple minutes is that CL1 is in the West region. It has a service. That service is replicated to CL2 and CL3, which are in East 1A and East 2A. And there's something called locality-based load balancing that you can make use of when you're doing a multi-cluster installation. If CL1 were to fail, we could automatically shift all the traffic from CL1 to the nearest locality. So if I had a CL, let's say a CL4, which is living in West 2, we could set it up so that it goes to there because that would be the quickest path. And then only if all of the West instances are dead would it go to CL2 and CL3. Cool. And so things that we'll be modifying here, or at least I'll be showing, is how the cluster dependencies are set up and then how traffic is load balanced among them. Let's go back to the browser. So that's what these 3 clusters here are. You can see Admiral West 1, That's based out of US West 1B. Admiral East 1, that's based out of US East 1A. And similarly, US East 2A is set up there. What we have in the Admiral West cluster is we have an Admiral project, which has a bunch of Admiral components in it. Admiral, again, being the controller that's operating, making all of the operations on the controlled clusters, and then greeting being the destination service, and web app being the source service. So web app makes a call to the greeting service, and that call will be split across West and East, and then East 1 and East 2. Much like we saw with the multi-cluster app for book info, we have a destination rule, a service entry, and a virtual service. The destination rule for global being a little bit more complicated. Here you can see we have the locality load balancing setting. So more or less what it's suggesting is that any traffic that's coming from US West 1, and then going deeper into zones if you need to, will be distributed in this way to each of the other regions. Right now, traffic will go 49% to US East 1, 49% to US East 2, and 2% to US West 1. The service entry. The service entry isn't too informative. More or less, you just have 3 different services. Admiral will take care of pointing to the local service. If there's a local instance of the service, you can see that it's not making use of the MTLS endpoint. It's just using the local DNS. It's hosted on US West 1, that's the locality. And then these other 2 are actually the ingress gateways for the other 2 clusters, being hosted in US East 1 and US East 2, and we're going to be accessing them through the MTLS endpoints. And lastly, we have the virtual service. The virtual service just pointing port 80 to greeting.sample.service.cluster.local to defaults.greeting.global. So it's more or less just pulling the greeting.sample.service.cluster.local from the local context into the global context. So let's prove that that works first before I do anything else. We can stop sending traffic to that cluster. Let me make this bigger. Clear, clear. I forget the endpoint that I'm actually referring to. Default greeting.global. Okay, so I have a giant command saved. Let me show you what it's doing. Again, it's a while loop. What it's going to do in this while loop is it's going to do a kubectl exec into this namespace. It's going to find the pods that are labeled web app. Remember, that's the source service. It's going to get into that service, and it's going to make a curl from that service to the default.greeting.global and dump out the return. So what we see there, hopefully, assuming everything cool. So it's going to have a message from each of the clusters. Right now we see ahoy from Admiral East 1. Let me move things around. I'll move this over here. You'll see Admiral East 2 pops in there because that's also 49%. And then at some point in time, we should see ahoy from Admiral West. I don't know if I'm going to wait for that entire time, but maybe we'll get lucky. All right, well, I don't want to wait. So I'm actually going to change the rules. The global traffic policy on the centralized control cluster is how I'm going to do that without having to change all of the load balancing rules per each cluster. You can see here that I have the configuration. The configuration is, again, 2 to west, 49 to east, 49 to east 2. Let's edit this. I can send, let's make US West 1 and switch US East 2 and US West 1. Let's apply that. What's going to happen is that change. There's a control loop on this cluster to pick it up, pardon me, from within the Admiral namespace. And at some point in time, once that change has been picked up, we'll see this US West 1 get updated to 49 and this US East 2 get updated to 2. And then we'll see the corresponding traffic shift over to West 2. If it doesn't happen in a couple of seconds, usually it's, I think the control loop for this guy is, control loop for this guy, oh, there's a lot of stuff going on there. Oh, there we go. West has showed up there once. It should start showing up there more frequently. Well, it's not happening very quickly. So what I'm going to do here is I'm going to investigate why it's taking so long, see whether or not it's actually made the change. Going back to the Rancher portal might be the easiest way. Oh, there we go. Now West is joining the fray. Cool. Try dashboard. Now we can see it's just West and East 1. We should see the destination rule has changed. Destination rule here has changed US East 1, 4949. If we went to the other clusters, we would also see that destination rule change, 49 to 49. And then US East 1, destination rule, 49 to 49. So apparently the demo gods were gracious today and everything seems to be going smoothly. The other part of the Admiral components is to know when a cluster needs to be updated. The way that that's managed, if we go back to US West 1, which is the control cluster, we'll see there's a dependency object. That dependency object has this pretty minimal spec here. You're specifying destinations. So from the source cluster, if you recall the components to make a multi-cluster mesh, they all rely on components more or less from the source to the destination. The destination usually is fine taking care of reacting based on just normal configuration. We have, so the destination being the greeting service, the identity label being a label that tells us which services on which cluster to watch, with those being identity, and the source traffic being web app. The source traffic being web app becomes important when you look at the virtual service. The virtual service, actually, no, I guess it's in the, oh, it's in there, here and there. So if we go back to the dependency, we know that we want to find applications that have the identity and the identity label set to greeting. If we go into this cluster and we look at this greeting app, let's view it in YAML. I can actually change that back. We can see, I don't like this view, I'm gonna go back to Rancher. Admiral West, Admiral, greeting, view edit YAML. Here we'll see that we have identity greeting. If we were to remove this identity greeting, it would pull off this cluster because this is the only application that has that identity element from the watch, and that would remove the ingress for that cluster. I haven't tested this, but I'm curious whether or not it can actually be done in real time. Let's save that. That'll upgrade the workload. That's US West 1. So that means the traffic will no longer go to US West 1 after it picks up the new configuration. Destination, oh, that would be stored in the service entry. Service entry, we're still seeing that. At some point in time, it will go through and remove that. So then we just have US East 1 and US East 2. I don't exactly know how Admiral handles the previous installations. I'm assuming that it keeps all of that context within the controller. I haven't dug in too deep. It's still only supported. If we go back to the presentation, actually. It's still only supported in the in the AWS region, and it's supported on Istio's version 1.5 and above. So you'll have interesting behavior if you use less than 1.4 or 1.5. It's the install. It is open source. Let me show you the open source code. Istio Admiral. That's not what I want. That's the blog post. Let's make that bigger. Here you can see Admiral. It has some docs. If you want to go through and set up Admiral yourself, the way to do that is to go to Docs, Examples. You'll see the prerequisites up here, and then it has various script elements that you can follow. One of the things I mentioned in my slide deck is don't forget this step. That step is important. It'll take you through the process of setting up the single cluster, setting up the multi-cluster, which you can rinse and repeat, choosing a different cluster each time, and then setting up global traffic policy, like I showed you first off, and then doing Argo rollouts to do more of a canary/blue-green deployment. So as I'm getting close on time, I'm gonna wrap up with Admiral, go to my final thoughts, and then open the floor to questions. So back into the presentation. Final thoughts, additional topics. I talked about failover, MTLS, and cluster autonomy. Some of the main reasons that you'd want to run multi-cluster applications, and that you want to make sure that once traffic leaves, any traffic that leaves the cluster and rejoins a cluster or rejoins another cluster, you can trust. You want to make sure that you're within reason, distributing your traffic across various environments. You don't want things going back and forth across the country or the planet. And then you want to be able to independently manage these Kubernetes clusters, but also not have to maintain many manifest files. So the automation, it's getting there, but I don't think it's quite there yet in total. I would still personally prefer, if I were responsible for a production multi-cluster mesh, I would roll my own automation. But things we didn't discuss today are what happens. Would you be able to have a mesh that spans multiple cloud providers? You certainly could. So technically, as long as you have the connection between the two, and they have the right dependencies as far as Kubernetes and Istio is concerned, it's just one cluster communicating with another cluster. One thing that I've personally been trying to play around with is using multi-cluster mesh to span environment boundaries, dev, QAT, and prod. So my use case here is that I want to show an example of production traffic going through an Envoy filter, that Envoy filter encrypting, salting all of the personally identifiable information, and then sending the actual production workload traffic to your QA instance, so you can properly scale test all of your QA instances. I still have work to do with that demo for the Envoy filters. Envoy filters is something we didn't even talk about with Istio. It's a pretty robust ecosystem, but I just don't have the time for it these days. Thirdly, we have meshes that span mesh frameworks. One of the reasons why this enters the conversation is that most cluster meshes are using the Envoy proxy. And so assuming that you have the ability to dive in through the abstraction layer that maybe console, mesh, or link or deep puts on top, and get to the actual configuration of Envoy, then you should be able to connect the two. Maybe go from Istio to console, console to Istio, so on and so forth. That's definitely more of a 300 to a 400 level class, but it's definitely interesting and doable, and I see a lot of utility in it. And last but not least, assuming that you don't want to take that 300, 400 level course, I've been following the guys at Service Mesh, or at Solo.io. They have a product called Service Mesh Hub, which is open source. They're more or less treating what we did today in the same way that Admiral is, and that there's a centralized location with service mesh, the hub for the service mesh, and that gives you the ability to introspect into your virtual mesh at large. So being able to see how DNS is being handled across the cluster, seeing what clusters are dependent on which other clusters, and they're moving forward the discussion of multi-cluster mesh, and they're also working towards with the Kiali group of making sure that tracing is available there. So that's all I have. I think I'm decent on time. 3:10 here on the East. If I've said anything today that you'd like to talk about, feel free to join the Rancher user Slack, slack.rancher.io. If you have any questions about Rancher specifically, or again, if you have any questions that based on what you heard today, https forums.rancher.com. Everything that we do is open source. So if you're trying this out and you find an issue that you think is related to the Rancher product itself, file an issue there, and it'll get addressed pretty quickly. And then at some point in the near future, I will be taking all of the information in this presentation and condensing it into a blog form with a little bit more of a guided tour of how to set up multi-cluster mesh. Cool. So at this point, hopefully I didn't lose everybody. Let me dig through the questions. If anybody has any questions. I see a couple questions that weren't answered. I'm going to start from the top to the bottom and work my way through them. The first question that I see is, can you talk about observability, how it is implementing in multi-cluster config? I don't want to conflate Kiali with observability. There is definitely two different definitions there. But as far as service mesh goes, Kiali is usually the go-to standard. If I wanted Kiali and in combination with Jaeger and tracing. But one of the things that I think I made reference to on the slide deck and this one, Kiali and Jaeger don't yet cross the cluster boundary. That's something that still needs to be done. Jaeger part wouldn't be so difficult because the tracing, you just need to pass the right headers and make sure that the headers are being observed. The Kiali part's a little bit more difficult, primarily because of the dependencies it has on the oblig configuration. What about what happens? What can be used? I think I answered most of the questions that are in the chat there. Does anybody else have any questions? I know I went pretty fast, but I had a lot to show. Will you ever be doing a Kubeflow demo with a DEX option? I imagine if there's a clamoring for it, I'd be more than happy to do that. I don't know if you're making reference to the fact that I wrote a Kubeflow article or not, but I do have familiarity with it, and I would be able to go over a basic class of that. There we go. I was sorting the questions wrong. Oh, okay, cool. Well, I appreciate that you read it. I'll actually put that on my short list of things to look into. One of the questions that just popped in is how to get visibility of results when we mirror the prod traffic to non-prod traffic. So the visibility of the, again, this is a solution that I'm still working on. The mirroring part is pretty straightforward. You basically just have to add a mirror configuration to the service, to the destination role, I think. And then you get the traffic split. But monitoring part, the visibility of the results, they would be still in the independent cluster. So you'd see like we saw in, let's go back to Rancher, where we saw in the Kiali dashboard, the details page, for instance, details, defaults, resource Istio, traffic graph. We would see it enter the ingress and then whatever the microservice internal to the cluster does. I would, if you're going to go the route of salting, encrypting, and then mirroring the production traffic, I would start with the use case of doing everything in cluster after it enters the QA cluster. Don't try and boil the ocean in one step. At some point in time, it would make sense to branch back out into multi-cluster mesh in the QA space. But you'll see the immediate value if you clone the traffic to the QA instance and then have the QA traffic bounce inside the QA cluster. Anybody else have anything pressing? I still have these environments up. If anybody would like to see something specific that I kind of breezed over real quickly, I'd be more than happy to show that. I didn't show much of the traffic metrics. Oh, that's still going on. Let's see what we're reporting from this cluster. Admiral, resources, Istio. Admiral is not installed. Oh, right. I did some interesting things with the Admiral Istio, so it's not going to be reported through the Rancher UI. Info ratings. Let's try the ratings. Let's try the review cluster actually. Review cluster, default, resources, Istio, traffic graph. Yeah, we're still not receiving traffic from that one. Okay, so I won't go into that. We are approaching time anyways. All right, I think that brings us, barring any last minute questions, anybody that gets in under the radar, under the buzzer. I'm building a kubeflow cluster with a DEX option using Rancher, but hitting the RBAC access denied. Any tips on troubleshooting? Well, I would suggest taking that offline, actually. I'm available on the Slack channel. I could talk to you immediately after if you are also on the Slack channel. I don't have any one-stop solutions, but I might be able to tease out the actual problem you're running into. All right. Well, with that then, I think that just about wraps it up. Thank you, everybody. If you need to reach out to me on the Slack, you can find me at @shipwreck, or if you need to reach out to me through email, jason.skrzypek@rancher.com, SKRZYPEK. It's probably easier to find me on through Shipwreck though.
Thank you, Jason, for this great session. Lots of good content here. As I mentioned earlier, just to wrap up, we will be sharing the recording and the slides in a follow-up email, so you guys will have access to this content. Also, as Jason mentioned earlier today, all of our projects and our products are open source, so head over to rancher.com to check out all of our offerings. And a couple of you guys had asked about the Rancher training and the certification process. As many of you are aware, it is live. If you head over to academy.rancher.com, you can get all the details and enroll if you are interested. And also for the upcoming virtual events, head over to rancher.com/events and you'll see all future sessions listed there. Thank you all again for attending, and I hope everybody has a great rest of their day.